Now, in the examples that we saw before, the elimination method just kind of worked, as if by magic. I'm going to show you an example now where the elimination method requires a little bit of preparation first. Let's say we start with the system 4x minus 2y equals 10. 5x plus 4y equals negative 7. Now, it would not be wrong to add together the left-hand sides, add together the right-hand sides. That would give us 9x plus negative 2 plus 4 is positive 2y equals 10 plus negative 7 is 3. This is not wrong, but it's not helpful. It doesn't get us any closer to a solution. And why not? Because neither variable was eliminated when we did that. Do you see the problem? In the examples we saw before, one or the other variable had coefficients that were opposite one another. And we don't have that here. 5 is not the opposite of 4. 4 is not the opposite of negative 2. But it's pretty close, isn't it? Do you see something that I could do to this first equation to fix the problem that we have? I could multiply both sides of this equation by the number 2. So I would get 2 times 4x minus 2y equals 2 times 10. 8x minus 4y equals 20. Now I'm going to copy the other equation below that. 5x plus 4y equals negative 7. And now you can see that the coefficients of y do that nice thing that they need. They have opposite coefficients, which means that when we add the left-hand sides together, we'll get 8x plus 5x is 13x. Negative 4y plus 4y will be 0y equals 20 plus negative 7 is 13. So the y was eliminated. We divide both sides by 13, and we get x equals 1. Now, why did we choose 2 to multiply by? We chose 2 with this goal in mind. Our goal was to get a negative 4 that would eliminate this positive 4. Multiplying both sides by 2 was the simplest way to get that. Alright, now that we know x, we can find y. I don't like to use equations that I've already manipulated for elimination to find my other variable, because if I made a mistake in this step, it'll be harder to catch. So I'm going to use just this first equation that we started with. 4 times 1 minus 2y equals 10. 4 minus 2y equals 10. I'll subtract 4 on both sides. Negative 2y equals 6. Divide both sides by negative 2, and we get y equals negative 3. Seems like our solution is 1 comma negative 3. Let's quick check and make sure by using this second equation. 5 times x is 1 plus 4 times y is negative 3. Does that give us negative 7? All this will be 5 plus negative 12. Yeah, that does give us negative 7. So that actually worked out properly. 1 comma negative 3 is the correct solution. I'm going to give you one of these to try. Solve the system 4x plus 6y equals 8 and 5x plus 3y equals 1. Pause the video and try this now. If you aren't sure how to start, I'll give you a hint in a moment. Your hint is multiply the second equation by a number so that you will be able to eliminate y. If you haven't already, pause the video and try again. Alright. Now what I see here is that 6 is a multiple of 3. So I can multiply the second equation by negative 2. Why negative? Because I would like to have negative 6y. Negative 2 times 5x plus 3y equals negative 2 times 1. So I get negative 10x minus 6y equals negative 2. And now I'm going to copy out the second equation just so I can see what I'm doing. When I add these together, negative 10x plus 4y is negative 6x. Negative 6y plus positive 6y will be 0y. The y has been eliminated. Negative 2 plus 8 is positive 6. Alright, divide both sides by negative 6, and I get x equals negative 1. Now I just need to find y, right? I'll use this second equation. 5 times negative 1 plus 3y equals 1. Negative 5 plus 3y equals 1. Add 5 to both sides. 3y equals 6. Divide by 3, and I get y equals 2. So it looks like our solution is x equals negative 1, y equals 2.